Hello, my name is Chris Hartman, and I'm the Education Program Manager for Mathcad at PTC. And I would like to welcome you to PTC's home state of Massachusetts for the AMATYC Boston 2010 conference. We at PTC are really excited about this year's AMATYC conference because for the first time, we are the official mentor sponsor of the AMATYC Student Math League, and will be providing all of the moderators for the 190 SML teams with complimentary copies of Mathcad 15 to prepare problem sets and answer keys for their teams. If you are unfamiliar with Mathcad, let me tell you just a brief bit about it. Mathcad is a very powerful tool for problem solving, mathematical exploration, and the presentation of mathematical solutions. It is also a flexible tool for creating publication quality problem sets and answer keys, tests, homework assignments, or textbooks. Mathcad enables teachers to create dynamic simulations using its video tools to help students better understand mathematical concepts. In order to showcase how Mathcad will add value to students' participation in the Student Math League this year, I'm going to illustrate for you 5 different ways that Mathcad could be used to solve this problem from last spring's AMATYC Student Mathematics League competition. I want to show you these 5 solutions because we at PTC believe today's computational tools are changing the game of mathematical analysis and problem solving. In the high-tech modern workplaces where your students can ultimately land high-paying jobs, computational thinking and problem solving is the best practice approach in problem solving and simulation. We know this because this is what our customers tell us every day. Engineers, scientists, statisticians use computational tools to do their analysis, their problem solving, because they want to make sure that it's right every time. So we want to show you how Mathcad 15 can help you to better prepare your students for a bright future in any one of these exciting STEM fields. So here's the first solution. One of the things that I, as a math teacher, I was a mathematics teacher for 14 years, one of the things that I value most about Mathcad is that it maintains for students and for me as a teacher the capability to present a pencil and paper solution, albeit by typing, right within the same intuitive whiteboard interface where I'll be able to make graphs and use a computer algebra system. So in this case, what I've done essentially is I've taken a solution I might have written step by step with a pencil to show all of my steps in solving a system of equations, and I've used Mathcad's Boolean equal sign to show each step of the solution and derive my final answer of 28/5. You'll see in this example how Mathcad's interface enables users to express their ideas using standard mathematical notation. You'll see how Mathcad enables students to produce textbook solutions. Very well organized, very well annotated. And you'll also note that there are 3 different equal signs that are being used here. A Boolean equal sign, which appears in bold, an evaluation equal sign, which is not bolded, and an assignment equal sign, which is colon equal. We believe that 5 equal signs are better than 1. Come to our booth and ask us why. Mathcad also has a powerful computer algebra system. So here's a solution using Mathcad's symbolic solver. It's very much similar to solution 1. It is also much briefer. Students with strong conceptual knowledge can often imagine symbolic solutions, and Mathcad's powerful computer algebra system enables students to creatively and efficiently make use of symbolic strategies that they know well. On the right side of the screen, you'll see the evaluation toolbar, which showcases Mathcad's 5 different equal signs. Those are the first 5 symbols from left to right. And beneath that, you'll see the symbolic tool palette, which lists a number of the most commonly used symbolic features. Mathcad has many, many more. Notice here also how Mathcad's integration of text and graphics around the standard math notation in the computer algebra system allows students and/or teachers to explain their strategies and show their steps. In both yellow and purple, I've highlighted my identification of the steps and ultimately my explanation of how I use the symbolic solver to generate the solution. The third solution that I'd like to show you employs matrices. Matrices are critical in engineering calculation, particularly in many of the fastest growing fields like bioimaging and biomedical engineering. Yet, in our algebra courses, in secondary school, in college, even a little bit, we avoid them because they can be tedious. Mathcad has excellent matrix tools. So it has the capabilities that you need to teach your students how to use matrices effectively to solve problems, particularly real-world problems. Notice here, once again, I'm solving the system of equations, but here I'm using a matrix technique. Notice how thoroughly I was able to document my solution so that the brevity and conciseness of the matrices is supported and explained because I've included my thinking. Notice also in the last line that I've included mathematical regions in the text box. In my fourth solution, once again I'm solving the system, but this time by graphing using Mathcad's excellent graphics capabilities. Visual thinkers love using Mathcad's powerful graphics to explore and to solve problems. In this case, I've employed Mathcad's intuitive zoom and trace features to generate an exact solution directly from my graphs. Notice that I've also used Mathcad's cast tools to take my original equations and solve them for the variable a so that I could graph them easily. Finally, I tried to think out of the box a little bit and came up with the idea of using a matrix to test the 5 possible answers. I think that one of Mathcad's greatest strengths is that it gives students the technology to attempt unique solutions with little extra effort. In this way, it supports and promotes creativity and innovation. In this example, I've used an array with the 5 possible answers, A, B, C, and D, and E, and I've called it choices. I started off with my system of equations again. I solved it for one variable B. I had B as -6 over -5. And then just next to that solution, I've written an assignment statement. A is assigned the value of choices minus B, and then beneath that, where you see 4 different arrays, you can see the value of A, and then you can see the value of twice A, and then you can see the value of twice A plus B. Twice A plus B being my first equation at the top. And I know that twice A plus B is supposed to be 10 within my system. And of the 5 choices, the only one that produces 10 is the value 28/5, which means the only choice that could possibly be correct is 28/5. So what have I done? I've tested all possible solutions, somewhat of a guess and check approach, but I'm checking all 5 answers at the same time. And in doing so, I've actually shown that one solution works and proven that the other 4 solutions do not work. Perhaps a little bit contrived, but also, I think, somewhat interesting. And it showcases Mathcad's ability to perform algebra using standard notation on matrix vectors. So I hope you've liked what you've seen. Mathcad has many, many capabilities. I'm sure that some of your favorite problems would work well and work very differently if you and or your students were using Mathcad in your classroom. And I encourage you to think about it. Think about Mathcad as the mathematics notebook for the 21st century. Much more than a computer algebra system. It's a powerful communication tool. So here you see information for downloading a free trial of Mathcad or learning more about using Mathcad in STEM education, either on our website, our blog, in which I frequently write, or the Mathcad Academic Twitter, where I share STEM resources. Please stop by our booth, number 336, at AMATYC, and introduce yourself to me, Chris Hartman, the Mathcad Education Program Manager, or to my partner, Ned Daniels, the Business Development Manager, and we'll have other people at the conference helping us, but we look forward to meeting you. Thank you very much. Enjoy Boston.